All right, so today we're looking at the least squares regression line. So what that is, and we're actually going to fit that to our data. So what we've seen is so far is that we've had a scatter plot. So we've decided what the response variable is, and we've decided what the explanatory variable is. So for an example, remember we could use height and weight. These are just examples, okay? And then we had a scatter plot, and we looked at the R value and talked about the strength. So now what we're doing is we're getting that least squares regression line, which is like the line of best fit. It judges all those points and it balances the line. And what it does, how it does that, is it minimises the sum of the squares of the residuals. You don't need to worry too much, but that's what it's doing. It's like balancing the line in between all the dots to get like a line of best fit. So this is the least squares regression line. That's what that's called. So if we've just gone over there. So instead of writing, it is a straight line, and we're used to writing, we're used to seeing a straight line being, y equals, you might have seen mx plus c, but we're not going to use those variables anymore. Now we're going to use y equals a plus bx. It's still a straight line pattern. They're just using different letters for the same. So if we have a look at it, this b is the same as your m. So the b is like the slope or the gradient of the line, okay? And now the a value here is the same as c, what you're used to, but a is the y-intercept, yeah? So it's where it would, if this line continued down and cut there, that would be the a value there, okay? So we're going to be looking at getting this. This is the next part of what we're going to do so we can analyse it. We get this data, we think there's a relationship, we want to get a formula or an equation that links it together, mainly so that we can make predictions. All right, now just this down here is a little warning that you really need to make sure that your EV and RV are correct before you go ahead, because obviously it'll make a difference if you pick them the wrong way. So always check that. If you're unsure, you should come and ask me and we'll get used to that. Otherwise, they're a little bit hard to tell. They normally tell you in the question. All right, so today we're going to look at other ways we can find. There's a couple of ways that we can find the A and B value. Our calculator is one way, and another way is we can use this formula. And these formulas we can use if you have a look there. So they're finding the B value here, and they're using R times SY and SX. So you might want to, so this is a way to find this B value a different way. So if sometimes when you're not given the lists, how we've been getting lists of data, sometimes you're not, you're given these other values. So what R is, if you have a look down here, R is the correlation coefficient, which is what you're used to. So if they tell you the correlation coefficient is blah, 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 you're getting given the R bit. Now, SY and SX are the standard deviations of the X and Y. So really, you might want to write up here, let's write it up here, SY equals the standard deviation of the response variable. So they might not use Y because we're talking about real data. So standard deviation of the response variable. So what they've done is they've got the list and they've found what the standard deviation was of that thing. And obviously, SX equals the standard deviation of which variable? What's X? EV, which stands for explanatory variable. Okay, so you might, because if they do a worded question, they're not going to say X and Y, they're going to use the variable names. All right, so there's the formula for that. Now, if we go down and have a look at the formula for A here, so A is like the y-intercept, remember? They're using, you can see they're using these, the mean of y and the mean of x, and you can also see they're using B. So you can't find A using the formulas until you have found B. So they definitely you have to find this one first so that you can find that one. All right, so let's write down what that actually means. That means they've found the mean of the response variable list. Yeah? Response variable list. And what would the other one be? So what would, this symbol means mean of x, but it's going to be the mean of the, which variable? Explanatory variable, good. So just so you've got that. So you might want to write this in there so you're aware, because they're just saying here, sorry, this is missing that little line there. So hopefully yours might not have it. You might need to add that. All right, so that's what that is. So let's go have a look at some questions, or a question that it's got it. So here it said the heights and weights of 11 people have been recorded. So they told me there that that's X. So I know this is the explanatory variable and this is response variable, but that makes sense because that's an example we use often. Okay, and they've given you the following statistics. So here I can see the mean height. Oops, sorry. Okay, so they've given you here the mean of X, so that which is height. So the mean or average height was 173. Then they've given you the standard deviation. They've told you the mean weight was 65 kilograms, so on average. And sorry, the SY, it got moved over here, so we can just put it there, 5943 kilos. That's the standard deviation. So it says use these formulas to find the least squares a regression line. So when they ask you to find the least squares regression line, what you're finding is the y equals a plus bx. So you're going to find a and b, and then you're also going to write it in terms of the variables. So use the actual name. So let's go use those formulas. So b was, if you look at the other page, it was r times sy over sx. So if you look up here, they've given you all that data. So r was here. So it was 0.8502 times SY, which is there, 7.5943, and divided by SX, which is 7.443. And we're going to get a value. So okay, so that ends up being they didn't say how many decimal places. So you know what we do? We'll practice. And I'm going to say to 3 significant figures. Let's practice doing that. Okay, so this is the answer that I get on the calculator, 0.867331. Okay, who's going to show me what 3 significant figures? Let's practice that. You start counting as soon as you have a non-zero. So here, 1, 2, 3. Does that go up? No. So 0.867. That's B. Okay, so now we're going to do the A value. So the A value formula was where you take the mean of Y minus B times the mean of X. So we have all those numbers there now. So let's do that. So it'll be what was the mean of Y? Was 173. So 173, no it wasn't. What was the mean of Y? Oops, did that wrong too. 65. So 65.4545 minus B, which I found over here, 0.867 times the mean of X, which is 173.2727. So let's do that one on the calculator, and then we'll round to 3 significant figures. Okay, so that ends up being negative 84.7729. All right, boys, so let's go through this. We want 3 significant figures for this number. Okay, so we're going to start counting. There'd be 1, 2, 3. Looking at that, does that need to go up? Yep. So it will be negative 0.8. Okay, there's the B value. Now we're not finished there. We have to write the whole equation out now. So what we're going to do, sorry, I'm just moving all that up a bit. We have to write the equation using the actual variable names. So the response variable was, so really what we have is we've found that y equals A, which was negative 84.8, plus B, which was 0.867 times x. We're not going to write that now. We're going to write it out using the variables. So y was actually the weight. So the weight, and I'll put the units, which was kilograms, equals negative 84.8 plus 0.867 times height in and centimetres. And we'll put it like that. That's the final answer. That's writing the least squares regression line, okay?